Okay, so we will be looking into how packet travels through the internet, focusing on layer 2 and layer 3 information. The first thing, let's have a look at encapsulation and decapsulation. So when a user sends the packets, he is the sender, and when the receiver receives the packets, he is the receiver. The sender sends the packet. Just think like this way, like he has some data in his browser, and you see here the data in his browser, which is application layer. As the packet goes through different layers, more and more data is added, and they call the whole thing, like here is called PDU, packet datagram unit. Here it becomes the PDU for the next, it becomes the PDU, like this whole thing will become the PDU for the next one. Here it becomes the PDU, the packet datagram unit. So at the end the packet forms, which becomes a packet. Now we are focusing on layer 2 and layer 3. In layer 3, the most important thing is sender's IP address and the receiver's IP address. In data link, we have sender's MAC address and the receiver MAC address. Now here things will change a bit as we go, but just remember layer 2 has the MAC address for both sender and receiver. Layer 3 has got the IP address for sender and receiver. The encapsulation happens, a big packet is formed or a complete packet is formed, and after that it is sent through the medium, whatever you are using, wireless, Ethernet, fiber optics. It arrives at the receiver's end and the decapsulation happens, where it is opening the packets. And the last stage is the data. The user, the receiver, is able to see the data. In short, if you look at here, the sender starts from layer 7 and the receiver ends at layer 7. Okay. Now we will go through this topology where we have the sender and the receiver. Before we go there, a few things. IP config, it gives the IP address. Okay, not much about the MAC address, or let's say the things that are in operational. It doesn't give things. In most cases, you'll not find information related to your virtual interface and all these things. IP config /all, it gives a lot of information. So if you look at here, a lot of information: host name, MAC address, DHCP, NetBIOS, a lot of things. You see a lot of information. And it also shows you all the virtual interfaces that you have. Okay, for example, if you're running VMware, Hyper-V or something like that, you will be able to see the virtual interfaces here as well. And there is another utility tool that we can use, is tracert, or if you're using Linux, we use traceroute. It will show you the hops, the number of hops that we are using to reach to Google. Okay, the number of hops that we are using to reach to Google. Okay, so it has to go through all these routers to reach to Google's IP address. Now, if you understand this one, just look at here. This is the sender and this is the receiver, and he goes through a number of routers to reach to the destination. Now, a complete packet has sender's IP address, receiver's IP address, sender's MAC address, receiver's MAC address. The first important thing about the MAC address is it never travels out of your network. That means if you are not connected in the same network, you won't be able to know the MAC address. You will never be able to know the MAC address. So if you look at here, this is the source and this is the destination. And if you look at here, even though their IP addresses are same or something, here it's not same. They cannot be in the same network, because if you look at here, the router already divides into two networks. He divides into two networks. He divides two networks. He divides. So they are not in the same network. You will never be able to know the MAC address of this device. Now the question comes here. If I don't know the MAC address, how would I put the receiver's MAC address in layer 2? That's the first question. That's the first question. You might have the same question. Then how do I know the receiver's IP address as well? Receiver's IP address can be known through DNS. For example, if you don't know Google's IP address, just search, okay? Do NS lookup, open the CMD, open the CMD, do NS lookup, type www.google.com. You will be able to see the Google's IP address. So knowing the receiver's IP address is not a big deal, but you will never be able to know the receiver's MAC address. Now let's come here. First of all, the sender is sending to R1, because the sender cannot directly send to the destination. He needs to send to R1. So if you want to send a parcel to somewhere in China, USA, wherever, in Europe, you need to send it to your local post office. It is the responsibility of your local post office to route the parcel to your destination. So you are sending the parcel or the packet to your local post office through this interface. So your source IP address and your destination IP address. As I said, knowing the destination's IP address is not a problem. You can use DNS to know that. However, you will never be able to know the destination's MAC address, because MAC address doesn't travel out of the network. Now, or if you are not directly connected. Now, if you look at here very carefully, now for this stage, my statements are true, but in the real life, you can know the MAC address. In the real life, you can know the MAC address even though you are not in the same network or even though you are not directly connected. Okay, VPN could be a good example of that one as well. Now, we are not talking about something very advanced, so let's keep that in mind. So we have the source MAC address, and he is directly connected on this interface, or they are in the same network, so he knows the destination MAC address. Now look at here, what is the destination? So this is 1 and this is 2. 1, 2, interface 1, interface 2, interface 1, interface 2, interface 1, interface 2. Now look at here very carefully. When he is sending the packet to him on this interface, at this interface the packet has arrived, this source MAC address and the destination MAC address is R1, 1, because 1 is the interface and R1's interface 1. R1, who is R1? R1 is the default gateway. R1 is the default gateway. So if R1 is the default gateway, so every packet that he has to send has to come to R1. And he knows the destinations of the destination MAC address of R1. Sorry, the MAC address of R1. And this will be the packet that is being constructed and sent from the PC A to R1. Now look at here. Where is the packet now? Look at here very carefully. The packet is now at this position. So imagine this is a person and he has got a left hand and has got right hand. if he wants to transfer something from his left hand to his right hand, does he need any permission, or is there any obstacles? No. So R1 can send the packet from here to here. Even though they are not in the same network, they cannot be in the same network. On a router, if you have multiple interfaces, they cannot be in the same network. They have to be in different network. But since it is on the same router, so they know the MAC address of each other. So it's not a big deal. So if you look at here, the packet is sent from here to here. So the packet is now here. Now look at here very carefully. The source IP and the destination IP never changed. So your address and your friend's address where you are sending the packet, the layer 3 address, which is the IP address, will never change. Now ask yourself, if the IP address changed, then actually your packet will never reach your friend. If the IP address changed, then it will never reach your friend. So there has to be some information related to your friend where you intend to send the packet. And this is the place, the layer 3, that will never change. Now look at here, the packet was at this point and the packet has been sent to this point. So the packet was, source MAC address was R12, so the packet has been sent from here to here. There is no big deal, okay? So this table has not been mentioned here, so don't worry about it. Now look at here very carefully. The packet is now here. As I said, like if you move the packet from left to right, you don't need any permission, you don't need anything. You can easily move the packet from left hand to right hand. Where is the packet now? The packet is now here. Now look at here very carefully. R1 does the decapsulation. He sees the destination's IP address and he knows that this is not his IP address. So if this is not his IP address, he won't be able to open the packet. He won't be able to decapsulate anymore because the IP address is not his IP address. But he knows someone who can send the packet to this IP address. So he knows R2 who can send the packet to this address. Now look at here very carefully. He has shifted the packet from 1 to 2nd interface. Now look at here very carefully. R1 is going to send the packet to R2. The packet will come from here to here. Now look at here very carefully. The source MAC address is R12 because the packet was here, and the destination is going to R21 because the packet is now here. Okay, is now here. Again, he will move the packet from left hand to right hand. There is no entry for that one because easily he can do that. And he will try to decapsulate and he finds that this IP address is not him. But he knows someone who can send the packet or route the packet to this IP address. That means the packet will be sending from here to here to R3. Now look at here, the source MAC address is R22. When R2 is sending to R3, and it will be received on this interface R31. So if you look at here, R3 on the packet has received here. In the same way, if you look at here very carefully, R3 will bring the packet from his left hand to right hand, and he is going to send to R4 because this IP address doesn't belong to him, but he knows someone who can send the packet to this IP address. Now, if you look at here, the packet will be sent from R3 to R4, will be sent from R3 to R4, and from interface 2 to interface 1. interface 2 to interface 1. R4 receives the packet, same thing, he doesn't know this IP address, but he knows someone who can route the packet to this IP address. It will be sent from 2 to 1. So R4 interface 2, which is this one, and it will be sent to R5 interface 1. Now look at here, R5 receives the packet and he knows this IP address and he will send the packet to him. So R5 so look, R5 will again shift the packet from left hand to right hand. There is no entry for that one, as I already discussed that one, and he will be sending to this interface. He receives the packet, he is sending to him. So this is the MAC address. He decapsulates. So the decapsulation, if you look at here, happens from layer 1 to layer 7. Now look at here. The first thing that he does is he sees his MAC address. He's very happy. These routers were able to see their MAC addresses as well, but that didn't help them. He sees his, so he sees, where is this one? Okay, this is the source is BBB. Okay, I think there is a mistake here. Okay, this will be the source. Okay, sorry. Okay, let's focus on this one, otherwise you will get confused. So he sees his MAC address, he's very happy, and he sees the IP address, which is the layer 3 decapsulation, and he sees his IP address. So he is free to decapsulate the packet all the way from layer 1 to layer 7. Okay, so the decapsulation is done here. He sees his MAC address, then he sees his IP address, so he will be able to decapsulate here as well, because that is his IP address. He has the permission to decapsulate in layer 3 because he sees his IP address, and after that he will continue doing that one, and he will be able to retrieve the data or see the data, what is there. All in all, the packet travels the layer 3 information, they don't change. However, the layer 2 information always keeps on changing, okay. Now that brings me to an important point. If you are sending the packet to Yahoo, if you are sending a packet to Google, to Microsoft, the destination MAC address will change, because Yahoo has a different IP address, Microsoft has a different IP address, Google has a different IP address. However, you are always sending the packet to your default gateway, and your gateway is always the same. So you will be always able to see the destination MAC address is your router's MAC address, So wherever you send the packet, if it has to go through the router, like for example, if it is inside the network, then you don't have to go through the router. The switch will handle everything. So in that case, your destination MAC address will be a MAC address of a PC or something, and that was the real true destination MAC address where you are sending the packet. However, anywhere you send on the internet, you will always find the destination MAC address is your router's MAC address, and it is always the same for any address that you send on the internet or to any other network that has to go through your router.